We're studying the calculation of elasticity. For more practice now, let's consider the case of Angie's ice cream store. Remember, when Angie lowers her price from $2 per cone down to $1 per cone, the quantity demanded at Angie's store increases from 20 cones a day to 30 cones a day. What I want you to do first is forget about the midpoint formula. Forget about what I told you was the right way to solve the problem. Why don't you go back to that old way and find Angie's elasticity of demand when she lowers the price of her product from $2 per cone to $1 per cone. But start by using point A as the base point for calculating percentages. That is, use $2 as your base price and use 20 cones as your base quantity. See what you get when you calculate elasticity of demand moving from this point to this point. Now, let's do those calculations together. The new quantity is 30. Subtract from that the old quantity of 20. That gives you a change in quantity of 10 cones. You want to divide now by the original quantity, which was 20, and that gives you a total change of 10 over 20, or 1/2, a 50% change in quantity demanded. Now divide by the percentage change in price. The price goes from $2 to $1. Take the new price of 1, subtract the old price of 2, that gives you -1, and divide by the old price of 2. Now we have -1/2, or -50%. If we take 1/2, the percentage change in quantity, and divide by -1/2, the percentage change in price, we get -1. Then apply the absolute value sign to get rid of the minus, and the elasticity measure, calculated moving from point A to point B, using point A as the base point, is equal to 1. We call this unitary elasticity, or unit elastic. Now, go from point B back to point A. That is, calculate the elasticity of demand as we move from a price of $1 up to a price of $2, and the quantity falls from 30 to 20. Only this time, use point B as the base points for your percentage calculations. That is, use $1 as your base price and use 30 cones as your base quantity. See what you get. All right, the new quantity is 20 cones. Subtract the old quantity of 30 cones and divide by 30 to get -1/3 as the percentage change in quantity demanded. The percentage change in price will be the new price of $2 minus the old price of $1 divided by that old price of $1, which gives us 1 over 1. So we have -1/3 over 1, which is -1/3. Apply the absolute value sign, and you get the elasticity measure moving from point B to point A, using B as the basis for your percentage, is equal to 1/3. Aha! We've recreated that problem that we had with the demand curve originally, with Barney's demand curve. We've recreated the problem that we get a different elasticity measure moving from A to B than we get when we move back from B to A. And that problem is all related to the way you measured percentages. Now, you know what the right way to solve the problem is. You know how to get a consistent measure moving from A to B or B to A. That is, you want to use as the basis for your percentages the point halfway between A and B. You want to use this midpoint in order to calculate the price and quantity percentage changes. The midpoint will be $2 plus $1 divided by 2, or $1.50. $1.50 will be the midpoint price. The midpoint quantity will be 20 plus 30, which is equal to 50, divided by 2 equals 25. Now, calculate the elasticity of demand for Angie's ice cream store as you move from a price of $2 down to a price of $1. Only this time, use the midpoint formula. That is, use $1.50 as your base price The new quantity is 30. The old quantity is 20. 30 minus 20 is 10. Divided by the midpoint quantity, which is 25, gives you 10 over 25, or 2/5. 2/5, or 0.4, is the percentage change in quantity demanded. The percentage change in price now will be the new price of $1 minus the old price of $2, that is -1, divided by the midpoint price, which is $1.50. And that gives you -1 over $1.50, or -2/3. So what we have here is 2/5 divided by -2/3. Apply the absolute value sign and multiply out, and you get 3/5. 3/5 is Angie's elasticity of demand moving from A to B using the midpoint as the basis of your percentages. Now, just as a check, find the elasticity of demand as you move from B back to A, again using the midpoint as the basis for your percentage. In this case, the new quantity is 20 minus the old quantity of 30 divided by 25 is -2/5. In this case, the percentage change in price will be the new price of $2 minus the old price of $1 divided by $1.50 for a percentage change of 2/3. Once again, applying the absolute value sign and multiplying out those fractions, we get the elasticity of demand for Angie's ice cream is 3/5, or 0.6. Notice then it doesn't matter whether you're going from A to B or B to A. Once you're using the midpoint formula, you get a consistent measure of the elasticity of demand in either direction. Notice that in Angie's case, the measure of the elasticity of demand is 0.6. That is, it is less than 1. If the elasticity of demand for your product has an elasticity number of less than 1, we say that the demand for your product is inelastic. That is, a given change in the price of your product results in a relatively small change in the quantity demanded. You can lower your price by a fair bit and not get a significant increase in the sales of your product. In this case, what happens is the smaller price has a big impact on your sales revenue. You're making less money on each unit of the good that you sell. And since you're not bringing in a lot of extra customers, your total revenue suffers. Anytime the demand for your product is inelastic, anytime your customers are relatively unresponsive to a change in the price of your product, total revenue will fall when the price of your good is decreased. If we go back to Barney's store, we'll see that his measure of elasticity was greater than 1. In fact, it was 1 2/7. What that means is a given change in the price of Barney's product or in Barney's market results in a relatively large response of customers. When Barney cuts his price by $1, he brings in a lot of new customers. And even though he's making less money on each ice cream cone than he was before, he's bringing in so many additional customers that his total revenue actually increases. Anytime the demand for your product has an elasticity measure greater than 1, we say that the demand for your good is elastic. And in that case, a reduction in the price of your good generates a big response from your customers, and total revenue increases. So, to summarize, if the demand for your product is inelastic, a reduction in the price of your good results in less total revenue. If the demand for your product is elastic, then reducing your price will increase your total revenue. If elasticity of demand for your product is exactly equal to 1, then the change in price and the change in quantity demanded exactly offset each other, and there is no change in total revenue. And use 25 as your base quantity. See what you get.